Right, let's check the quality of the video right now. You are being recorded. Okay. So for a starter, end of the day of the session, I'll take this little instrument and we can at least I can show you how to play this song ourselves. So you know, like we can do some jamming as well. Okay, that's for a starter. I love this song. I love this group. So, good morning, everyone. My name is Dmitry. I'm with the Canada Border Services Agency, and we're here at the Government of Canada Lunch and Learn meetups, which are happening every Friday starting at 11:30. Everyone is welcome. It's a time where we can see each other and ask each other questions and share with each other our knowledge and tricks about data science and R specifically. So the way I would normally start is by start sharing the screen, and this is what I will do now as well. I will show you the website on GCcollab where we update the information about the content which we're discussing here. So I hope you can you can see it now. So that's the page, and here in replies we have questions and answers which we have discussed in our previous meetup meetings. And last time on 9th of April, we had quite a few new people joining us. And one of the questions was, for example, how to transition from Excel to R. Because indeed, R is now approved by many Government of Canada departments, and you can run Outlook or you can run RStudio. And to do the same processing and plus much more. And if there's something interesting, we will start a new activity, or we will add as a reply to one of the ongoing discussions, we will get a reply and provide more information. So for example, because people were interested on how to transition from Excel to R, a new discussion thread has been created, which provides links exactly about this topic. So this is just how we're structuring our meetup discussions here. So again, I'd like to remind that we're recording this session because we will start actually training ourselves. So if you don't feel comfortable seeing yourself maybe in the screen eventually, because I'm planning to put this video somewhere so that people can browse it. Last time also at Lunch and Learn, we talked about the opportunity to present our work somewhere. Specifically, Stats Canada has just opened a call for proposals for their International Methodology Symposium, you see. So in fact, when we work with data science, it's very important to develop a good methodology. It's not just about getting a nice graph or some recommendation. If you cannot justify your recommendation or how you derive your outcome from input, there is not much trust. And in fact, you can introduce some bias or some issues into your problem. So this is a good opportunity to submit your work, your methodology to Stats Canada. I believe submission is next Friday. And in fact, I would like to make submission from my work as well. For example, I'm working on data linking packages or codes. So I would like to submit maybe a proposal for discussion on developing and evaluating different data linking packages. And another topic which I would like to submit is developing packages for common use by all government employees, and not only government employees, but anyone which deal with Open Canada data. So example of this data is, for example, COVID. And on your screen, you'll see right now, it's the code which we have developed last year at Launch and Learn, which reads the COVID data from University of Toronto repository, and it visualizes it, but not only visualizes, it does some smart, good things. It can automatically detect the zones or the health regions which are most contaminated, for example. So the idea is to take that code and to convert it to a package so that anyone can use it. And you can see the website. The website right now is rcanada.shinyapps.io/COVID. And so here, in fact, we can see it's for Ontario. Let me just click on Ottawa. I'm specifically very much interested in what's going on in Ottawa today. So it's a package which is called Plotly. Okay, so that's the situation. I hope you see the situation with COVID in Ottawa, right? In Ottawa and on Quebec side. Also, I'm adding Quebec on other side of the river. This is how dynamics of the trend of COVID is happening right now. Now, many of us are using a GC code, and we spent some time and have written some tutorial on how you can access a GC code. So I start developing a package, rCanada. And in this package, I hope again to put the code which will allow you to build this type of graphs from COVID, and then from something else, maybe PSS, public servant employee survey. So the code is here. I also put it into this repository. We have what is called R4GC. And this is the place where I'm inviting everyone to go and to make use of it. So this is where in the resources you will find information about GC code, for example, 101. And in folder codes, we can put some useful codes. And currently I put a code called CA COVID, Canadian COVID. So that's the code. It essentially has three functions. It has a function to read data from University of Toronto. Then it has a function called extract most infected places today. And then also a function called add derivatives, because essentially it's maybe functionals. Maybe it could be renamed create functionals of your variables, because normally in your data, in any data, you have raw observations, but then you develop functionals out of those observations, which become your input variables for your models, for example, for building some predictive models. So, and in order to run this code, you would just run something as that. It will be a line, read COVID U of t, add derivatives to it, and then we can visualize, we can select most infected, this extract most infected places, and then we can visualize with the GC ggplot, with ggplot here. So it's a ggplot in here. Many of us are familiar with ggplot. So now it's time to introduce our good friend and colleague again, Joe Stinciano, who has developed packages himself. And even some of his packages are on CRAN already. Many of you know CRAN, so this is where good packages, which have passed some quality check, are archived. And hopefully we can build something which is as useful or as good as some of those packages there. By the way, this is one of the packages I found recently called Janitor, which is cleaning, again, for data cleaning. So it gives you an idea where we're aiming at. So we would like to get out of some functional code. I'm just going again through application, COVID. This is the code which all of you will be able to access from here, and I will provide links. And eventually would like to build something like that. Now, how to do it exactly, I'm not sure. I had many questions. I know that I will create a new repository. I have in fact already created rCanada, and I know that I will be making some. It will have a special structure to the directories. But again, I have many more questions, so I'll stop sharing my screen right now, and Joe, you can start sharing your screen now.
Thanks, Dmitry. Hi, everyone. My name is Joe Cinziano, and I'm an analyst for the Canadian Food Inspection Agency. Can everyone see my screen right now? So, yeah. Okay. So I'm going to go over the basics of putting together the skeleton of an R package, because it has to have a very specific structure for all the different checks to go through when you're actually building the package. So the package dev tools is really handy for this. It's function create. What you can do is specify a file path, and it'll build a package with that name. So in this particular case, when I run this function, it's going to create a package called package building with a specific structure. And over here on the right, what it'll do is it'll set up specifically this project file, a namespace file, description, an R folder, and then these other folders, manuals, tests, and vignettes, you can then create extra. So with the structure of an R package, all of your functions need to go into the R folder. So in this case, there's one function file right here. And if we open that up, we can take a look at the function. Now, there's a second package called rOxygen that you can do to help annotate all of the different variables in a function. So if we create a function called myFunction here, so all that this is doing is adding 3 values together. If we click here and in RStudio use Control, Shift, Alt, and R, it'll pop up with a skeleton for the documentation. And then you can start typing in a description of each of the variables that goes in there. This return aspect provides a description of what the function actually does. So if we go back to this function, we can see we've got a description. This is one of the ones that Dmitry put together. And if I just load this package, let's see here. And then I look for help. So all that documentation that's up top here will help provide a manual for the function. So let's see. If we do this, it'll pop up with a help file like you see on your regular packages. So all of this extra information that you add up there is really important for actually making sure that others can look for help in how to use your function. So once you've initialized your package, with this, then you can start adding in some of the other infrastructure for the package. So whenever you do a package, if you want to make sure your code's robust, you need to make sure you're writing tests so that each function produces the expected behavior. If you use the function useTestStat, it'll create a tests folder right here. And then you can start nestling in your tests for that. Use vignette, that will create a vignettes folder. And so if you're unfamiliar with the vignettes, they're an R Markdown file that runs through how to actually use the code and provide some examples, usually pretty basic examples to get someone started with actually using your package. That helps to reduce the workload for the package developer so that someone can try and help themselves first before they contact you with any questions. And if you have any questions at any point, just feel free to stop and ask.
Joe?
Yes.
The very first step, what should be the very first step? So, because right now I have a file, this file, which I've shown on the screen. So do you advise me to create a new project or work in the same file?
So based on what I've seen of the structure of the repository, you'll have to create some different folder names because the R package construction won't work with the folder names you have in that repository right now. It's very specific. You need to have a folder named R with a capital R, and then the manuals folder will be created separately, and the description file, this is probably the hardest file to create. I'm not entirely sure the file type, but when you use the dev tool command create, it'll automatically create a bare bones description file. So I'd say your first step is to run this dev tools create to create a new folder that will have the structure you need for the actual package. And then when you're actually writing the functions, that code file that you have on there, you could keep all the functions in one file if you want, or you can separate them into different files. Now, the recommended practice is to have families of functions in the same file.
Yeah.
So if you have a bunch of functions that are completely unrelated, they should have separate files for them. But if they are related, you can nest them together in the same file. Does that make sense?
I have a follow-up question. I'm trying to gain some knowledge from your personal experience, because normally you don't develop package right away, right? You have some files where you accumulate all your useful stuff and some not useful. You have many comments that it's not clean. You really just write. It's like right now I have a file called ca-covid.r. And it may have many other things which I may or may not use later. So how do you do it yourself? Do you have two separate directories, like one where you have everything and one specifically for package, or again, do you put them in one place?
So with the projects that are going to be ongoing and I'm developing functions for, I just create the R package skeleton right away. And then in that R folder is where I'll put all the functions that I create, whether they're in the end product, it doesn't really matter. It's just having something in a package format so I can call those functions more easily. And then I do all of my analyses in the vignette files. So that's how I go about my workflow. So unless it's an ad hoc request for analysis, I usually use an R package structure for everything.
Okay, thank you.
So the description file is a pretty important component of the package because that's going to tell everyone who made the package, who contributed to the package, and as well as the other packages that are required. So it's got a fairly similar structure across packages. You may see some additional fields that may pop up in different packages. So you've got the title up here, or the name, and then the title, and then the versioning number. So whatever sort of versioning scheme, you have to use either a period or a dash for that, and then the authors. So here you'll put the contact information. Now, usually at least one person has to be the designated maintainer. And there's, I don't know that you actually need the maintainer field if there's just one author, but if there's more than one author, you'll have to specify someone who's going to be maintaining the package long term. You can provide a description and then the license. Now, this is going to be an important consideration for all of us if we're building our packages, because it might depend on what department you're in for what type of license you use for this. There are some restrictions to the types of licenses you can use on R packages, and you can find that on the R website where you download the program. Now, there are a couple important fields here as well. There's suggests and imports. So suggests is used to indicate packages that can be useful for maximizing the utility of the package. So for instance, R Markdown is useful for actually using the vignettes of a package. Same with knitter. Now, imports are the packages that your functions are absolutely dependent on. So for the function that Dmitry sent me, it's absolutely dependent on dplyr, data table, mgritter, lubridate, stringer, and so on. You can add to these fields manually, or you can use this code that just says use package with a package name and the type equals imports. So that's usually one of the best ways to do it. Another consideration is that sometimes you'll have to add the version number for a particular package, especially when you're submitting to CRAN. It's going to be important to specify the versioning. So for instance, you might add something like greater than 1.0.0, for example. So that would mean that if someone tries to install your package and they don't have dplyr version 1.0 or higher, well, let's see, it would be greater than or equals to. If they don't have dplyr version 1.0 or higher, it will ask them to install that package or the package won't run. So that's one way to ensure that when someone downloads your package, it works as expected, especially if you're depending on a new feature in one of those dependencies. So another component of an R package as well are the tests. So this is where you'll be checking the actual behavior of your function. There's this really useful function called test skeleton, which will generate a skeleton of a test for your function. So if we go to the tests and look at the one that I wrote for Dmitry's function here, a test file just looks like this. So it'll have some sort of a title, and when it actually runs and works, it will output this message, function name works as expected. If it doesn't, it'll fail. And so if you update an R package and then go to rebuild your R package and a key feature of a function is now broken, you'll be able to see that right away because the test will fail when you're checking your package. So this helps to make sure that when you make changes to a function or change the dependencies, that everything's still behaving in the same way. So what this test does is it's checking to see that when you replace, when you use Dmitry's function to replace the name Alberta with its short form AB, that it doesn't affect any of the other components in that example, and that AB appears in the output, and that the original input is no longer in the data table. So does anyone have any questions at this point?
Yeah, I'll get back to my previous question. It's very, very good what you're describing here. Can you please show again your directory structure, the original code which you have copied from GCcode? Do you still have it somewhere?
I think I saved it. I think, or no, I just copied and pasted it directly from GCcode into. I just pasted this function to start with.
Yeah, Now, would that be okay for you to put the same original code there, or does it need to? Does it have need to be only necessarily used by the package? You know, can I put something there which actually will not be used in the package?
Yes. Yeah, you can put stuff that you're not going to use in the package as well. So that is the thing about the packages is you can include any sort of functions or that you want in there, but there's ways to hide them from the user. So I haven't ever had to do that. So you'd have to read the documentation on how to do that, but you can create functions that the user doesn't ever see.
Okay.
And you can also have a file, and I'll have to look that up for next time, but you can put multiple functions in the same file. It's just you have to export each function separately within the file. So you'll see this little export symbol. You'll need at least that for each function in one file.
Okay. I'll let you continue.
Yeah. And I see there's a question. Does Python have similar rules, principles to build packages as in R? That I'm not familiar with. One of the main reasons why I've been able to build packages in R is because of Hadley Wickham's DevTools package, because it makes it really easy to build R packages. So I can't say what it's like in Python because I haven't used Python either. So let's see. I thought I would keep it really simple today for all of that. So let's just say we build a function. I'll show you how to actually, so I'll show you this manual section. So this folder has all the help files in a special format. So you'll see that this looks very different than the function file. It's got all kinds of different annotations in it. And this is produced automatically when you use the DevTools. So that helps to avoid any sort of errors you might make. So if we save this function called myFunction, now you'll see that there's no manual file in here, and we can use this command on DevTools called document. And what that will do is it'll take all of this information and put it into a help file. And so we should see, oh, I made an error in the description. So I'm just going to remove the versioning. It is very particular about the way you put information in. So if we rerun this code, you'll see now that the manual for my function has popped up with the exact same structure. So the DevTools package has a bunch of different functions that help you produce packages and produce the necessary annotations and documentations for your R package for submission. And it even has tools for submitting the R package as well. Does anyone have any other questions at the moment?
So I see you have created a sample function, myFunction. So,
yes.
But I don't see .r file anywhere.
Oh, I had it right here. So when you use,
it's in the same R directory.
It's in the same repository, but a different folder. So all the functions are in R, and all the documentation produced by DevTools goes into the man for manual folder.
So this R file actually, even though it's R, it's not in R directory, it's elsewhere.
It is in the R directory. So if I click here, you'll see myFunction in here. Okay. It's just when you produce the manuals, the help files, they'll go into the man folder rather than the R folder. And that's all done automatically. Now, if you have the skeleton of your R package ready, RStudio makes it easy to build. So as long as it's a project of the type package, you'll be able to use these tools. So whenever you're creating your package, you'll always start with clean and rebuild. And so that will compile it into an R package. It'll tell you if there's errors, and usually if there's errors in this step, you will not be able to actually create your package. So once you solve the errors here, it'll work, and then it'll load it with library down here. Now, if you want to check your package to see, is it CRAN compatible, you can go check package. And what this does, whenever you submit a package to CRAN, there's a server that automatically does all these different checks on the package. And when I built that function called myFunction, you can see it's missing a lot of information. It's missing all the descriptions. So there's going to be a lot of warnings that pop up here. But this check package, that's exactly what CRAN does going through the R packages initially. It's an automated process, and RStudio does the same one. Now, that's not to say that if your package passes the command check, it'll get accepted by CRAN, because the CRAN maintainers will take, especially if it's your first package or you don't contribute very often, they'll take a much closer look because they have a whole series of rules as to what can and cannot go into a package. So for instance, you're not allowed to create functions that automatically write to a person's computer. You have to force them to specify the file path. That's why in a lot of R functions like write CSV, you have to specify the file path, because our CRAN policies say that you can't do that. As well, you can't include executable files because everything's supposed to be generally safe. So if there's no executables, it's probably safer than if there was an executable. And this can take a while depending on the size of your package and what errors might come up. And then at the end, it'll give you a summary of all the errors, all the warnings, and all the notes. And so we're just waiting right now. And there's going to be a few warnings, and there might be an error. So are there any?
I have a parallel question to that. So in general, you know, you're working on a project, or maybe a couple of projects, and there are some functions which are used in both projects, right? So, and that's the dilemma I have right now for myself as well, because for example, this function which you are using right now, replace A with B, you know, it's something which actually does not belong just to rCanada package, which I'm going to develop. You know, rCanada package will be specifically to process, analyze OpenCanada data. And this function, it deserves, or it should be placed in a separate package, which probably I will be creating in parallel, in fact, where I will be adding my data linking packages or functions and my other things. So can you just talk a bit about how do you organize your codes? Let's say if you're developing some functions which are used in a couple of different places.
So there are going to be a couple options. In a lot of packages, when you go into their R folder, you'll often see a file that's just called utils, utils. And so that's where they'll put all those utility functions. So they don't necessarily create a new package for the functions they use in all their package. They just have this utils file that they just copy and paste into each package. That's one way to do it. Because if you want to actually link the packages, where you would have to link them is in the description file, and it would have to import your package with all those utility functions. So the challenge with that is it would have to then first be, I think, because I haven't tried linking it in that way before, but I think it would have to first be on CRAN, your utility functions, and then your main package would be able to import it from CRAN, because this imports only checks CRAN for the packages. It doesn't check GitHub or...
Yeah. So in fact, to be honest, that was my main stopper why I still have not developed a package, because, you know, there are so many functions which I'm using all over the place. And I just don't know where to place them. Because if I put them in a package, let's say rCanada, but I want to use the same, let's say, we're using good example, replace A with B, a very generic function. So what are you suggesting is that I can create essentially an extra copy of that function and just place it everywhere in each of my packages which I'm developing?
Yes, at least until you get it on CRAN.
Yeah, because that's not, you know, that's not the way we cannot expect, let's say, our nice utility functions will end up in CRAN very soon, right? But you are already using many of them for many years. So I'd like to somehow to make use of them, but I don't know how.
Yeah, so I would say create a utility file, like just call it utils, and then just put all your functions that you use in all your projects for right now. Now, when you do submit something to CRAN, it can take, let's see, it can take up to a week until you get a response back from CRAN. And if they accept it, it might be on CRAN within 48 hours. Other users might be able to download it, but if they don't accept it, then you kind of have to plan in like 1 week per round of review with CRAN, just because the maintainer, there's only, I think, 3 people who check over the packages at any given time. The advantage is that most of them are overseas. So if you submit your package right now, they might get back to you during the nighttime in Germany. So by the time you're starting your next day, you might have a response back. So there's sort of an advantage to our geographic location when getting CRAN comments back.
Okay.
Yeah,
okay. So in fact, while you're talking, you know, on my screen, I have already created a folder R in that GC code repo Canada. And in fact, now I'm creating a file there called utils.r, where I will start copying all those utility functions. And in fact, we can eventually have this utils.r file. It's open to everyone, so anyone can copy this file and place them into any your project. And I guess that's what I will be doing myself. Let's say I develop a new project, and I will just maybe keep a master copy of that utils file in my GC code folder. And then every time I need to use it, I will just place it where needed.
So one thing I would recommend doing in that master file is just this return section in the documentation where you describe what the function does. It would also be worth just putting that you developed it, just so that way the credit can be passed on if someone uses it in another project, for example, just to make sure there's that transparency as to who developed it and people get credit where it's due.
Makes sense.
Now, the R command check has run through. So when you submit a package to CRAN, you can't have any errors or any warnings. You can have notes, but you have to explain why those notes are acceptable. So in general, what you have to do is go back and find wherever there was a warning. So in this particular example, there's a warning because the package Q PDF isn't in there. So you have to make sure the package is incorporating that.
I guess you have included this package yourself, right?
I thought I included it in the description, which is where it should be.
Because I didn't have that package. So that's something which I guess you specifically added for a reason, right?
Yeah. So basically what you'll do is you'll go through all the warnings, and they're usually in a different color here, and just read what they are and then deal with it. So for instance, there's a warning because there's no license. So in that case, the solution is to go to the description file and make sure you modify the license to an appropriate one. And it's nice because it gives you that checklist of everything you need to do to get your package ready for CRAN. And there will be some cases where it's really tricky to get something to work, and you'll keep getting notes. And in that case, when you submit to CRAN, you can actually explain why that note should be acceptable. But in general, it's frowned upon to do that. You should just get rid of all the warnings and notes. And then when you think you've dealt with it, you'll run the check again, and it'll go through. So.
Okay. So is there anything else we need to know now, or myself? Let's say you will be away for next couple of weeks, and by the time when you are back, actually, I would like already to show the community and yourself how I have transferred my COVID functions into this new structure. And in fact, as you were talking, I have just already developed the structure on my screen. And before we finish our discussion today, actually, I would like to show you, and you will tell me whether anything else needs to be done. So, but before we do that, do you still anything to add on your side?
I think I'll stop there for now, because there are a lot more sort of nuanced aspects that we can go through in the next section. It'll just be good to give everyone a chance to try it out if they want. So.
Okay. So you see on your screen the folder, the repository which I have shown you in the beginning, and now you see there is a new directory called R. By the way, you see I kept my other directories there. Is it okay?
Yes. So there is when you create the package structure using that DevTools create command, there's an R build ignore file. So you could add those folders to the R build ignore file, and then it'll just ignore that when it's running through the command checks and putting it together. So
that's perfect, because, for example, in one of these folders is datasets, where I will be putting some datasets just for me to play with. They will not end up eventually in a package. And the same with the codes. You know, I will be putting there some codes which are not tested, which I'm just playing with, and they're not maybe meant yet for the package. So probably I will just keep these two folders the way it is right now. But now you see there is a new folder called R. And in fact, you see I have already created 4 files there. So utils R, I will even make a comment maybe when I go there that this will be a master copy, which will be located in this GC code URL. And then you see I have created 3 files, one which will contain everything related to COVID, Open Canada data, another one elections, and another one PSAS, because these codes I have already played with them. It will take me, once I know the process, it should take maybe, I don't know, maybe 1 hour or a couple of hours, maybe to actually to put all needed functions to visualize, to open, to visualize, and some analysis functions. So now all other directories, you say, will be created automatically once I run your first this line of code which you've shown in the very beginning.
Yes, yeah, so that I just put it in the chat. That command will create that basic structure. It'll create the description file, the ignore file, the R folder, and the project file, as well as the namespace. So
now it will not delete my 2 folders which were there, right?
So I think it will construct a new folder, but what you can do is move the files it creates into your rCanada folder. So in general, the first step you want to do is to use this create function and then put stuff into the folder.
Okay, yeah, I may probably what I will have to do, maybe I'll have to create a new one and then delete this one and move everything there.
Yeah, that might be necessary, but you might just be able to move everything into it and it'll still work.
Yeah.
It's always,
yeah,
that's why, yeah, it's always good to have a solid, like once you know how to build R packages, it's important to know when you're going to build an R package so things don't get too confusing with merging things. So
yeah, so we're running our 45 minutes, and I said that we can continue our journey. Mr. Postman, look and see. You there a letter in your bag for me? I've been waiting for so long time till I heard from a friend of mine. Wait a minute, oh yeah. Wait a minute, oh yeah. Wait a minute, oh yeah. Sooner the better, give me a letter. Because we were talking about packages, so my idea is for every meetup session we can end up with a theme. So, and maybe if anyone is interested in learning how to play guitar, we can have that as well. So, thank you, everyone. I think we'll keep it sharp, succinct. 45 minutes is good, and let everyone else to potentially learn how to do packages and maybe how to play a song called "Please, Mr. Postman." It starts from the tonic. We're playing in A major, La major, and then goes a parallel minor tonic, because there is a lot of theory. And then goes subdominant and dominant. So we can talk at a separate topic. We can have lunch and learn accompaniment one day. So thank you very much, everyone. Joe, merci beaucoup. Merci beaucoup. C'était grand plaisir. Vraiment pour avoir cette opportunité d'apprendre mieux. Et encore, j'ai hâte de me servir de tous les trucs, de toutes les connaissances que tu as partagées avec nous. Merci beaucoup. Et à la prochaine. Bonne fin de semaine, tout le monde.
Bye. Merci beaucoup.
OK.